Imagine a machine built before smartphones, before the internet, and before most of today's technology even existed. Now imagine that same machine still working nearly 50 years later, traveling through a region of space no human has ever visited. That machine is Voyager 1. Launched in September 1977, Voyager 1 began its journey as part of a mission to explore the outer planets of our solar system. At the time, no one expected it to become one of humanity's greatest explorers. Scientists hoped it would survive long enough to study Jupiter and Saturn. Instead, it continued onward, pushing farther into space than any spacecraft before it. Today, Voyager 1 is more than 15 billion miles from Earth. The signal it sends travels for over 22 hours before reaching our planet. Every message is a whisper from the edge of the known solar system. For decades, Voyager has been moving toward a destination that once existed only in theory, the boundary between our solar system and the vast ocean of interstellar space. In 2012, it achieved something extraordinary. Voyager 1 crossed the heliopause, the outer edge of the heliosphere. The heliosphere is a giant bubble created by the Sun. It surrounds the planets and shields much of the solar system from high-energy particles traveling through the galaxy. Crossing that boundary meant Voyager became the first human-made object to enter interstellar space. Many imagined that beyond this frontier there would be little to observe. Space between the stars was often described as nearly empty. Scientists knew there would be particles and magnetic fields, but the region was expected to be relatively calm. Voyager revealed a different reality. Its instruments detected that interstellar space is far from empty. Instead, it is filled with moving plasma, magnetic forces, and streams of energetic particles. Invisible structures stretch across enormous distances, shaping the environment between stars. One of the most fascinating discoveries involved plasma waves. Although space is a vacuum compared to Earth, it still contains extremely thin clouds of charged particles. These particles can vibrate and interact with magnetic fields, creating wave-like motions throughout space. Voyager's instruments detected evidence of these plasma oscillations, allowing scientists to measure the density of the interstellar medium surrounding the spacecraft. What appeared empty from a distance was actually a dynamic environment with constantly changing conditions. As Voyager traveled deeper into interstellar space, it encountered regions with different particle densities and magnetic properties. These variations suggest that the space between stars is not uniform. Instead, it resembles a vast landscape filled with invisible boundaries and structures. Scientists believe some of these features may be linked to ancient stellar events. When massive stars explode as supernovae, they release enormous amounts of energy into the surrounding galaxy. Over thousands or even millions of years, the shock waves from these explosions travel through interstellar space, shaping clouds of gas and influencing magnetic fields. Voyager may be passing through regions affected by such events, helping researchers understand how the galaxy evolves over time. Another important area of study involves magnetic fields. Magnetic fields are everywhere in the universe, yet they cannot be seen directly. Their presence must be detected through their effects on particles and radiation. Voyager's magnetometer has measured changes in the direction and strength of magnetic fields surrounding the spacecraft. These observations provide valuable clues about how the Sun's magnetic influence interacts with the larger magnetic environment of the Milky Way. Understanding these interactions is important because magnetic fields help control the movement of cosmic rays, high-energy particles that travel through space at incredible speeds. Cosmic rays can pose serious risks to future astronauts and spacecraft. By studying how these particles move through interstellar space, scientists hope to better understand the challenges of future deep space exploration. But Voyager's story is not only about scientific discoveries. It is also a story of survival. In late 2023, the mission faced one of its most serious challenges. Communications from the spacecraft became corrupted. Engineers could still detect Voyager's signal, but much of the transmitted information could not be interpreted correctly. For a spacecraft operating billions of miles from Earth, such a problem could have marked the end of the mission. Yet the engineering teams refused to give up. Working carefully, they traced the issue to damaged memory used by Voyager's flight data system. Because of the enormous distance involved, every command required nearly a full day to travel to the spacecraft and back. The process demanded patience, precision, and creativity. Engineers developed new methods to move software code into different sections of memory and restore critical functions. It was like performing delicate surgery on a machine located farther away than any object humanity had ever controlled. Months later, their efforts paid off. Voyager resumed sending meaningful engineering and scientific data back to Earth. The spacecraft that many feared was lost had returned. This recovery demonstrated something remarkable. Voyager is not merely surviving because of its original design. It continues operating because generations of engineers and scientists have adapted, improvised, and solved problems that no one anticipated decades ago. Meanwhile, the spacecraft continues its lonely journey into the darkness. On board Voyager is one of humanity's most famous messages, the Golden Record. This gold-plated disc contains sounds, music, greetings, and images intended to represent life on Earth. The record was never expected to be found. Its purpose was symbolic, a message from one small world to the wider universe. Whether anyone will ever encounter it remains unknown. What is certain is that Voyager has already changed humanity's understanding of space. It has shown that the region beyond our solar system is not a silent void. It is an active environment shaped by plasma, magnetic fields, cosmic rays, and the remnants of ancient stellar events. Each new measurement helps scientists build a clearer picture of our place within the galaxy. One day, future spacecraft may travel farther than Voyager. They may carry advanced instruments and powerful propulsion systems capable of reaching neighboring star systems. Yet those future explorers will follow a trail first opened by a spacecraft launched in 1977. Even now, Voyager 1 continues moving deeper into the unknown at thousands of miles per hour. It travels through a realm no human has ever seen, sending back information that expands our understanding of the universe. Far beyond the planets, beyond the sun's protective bubble, and beyond the familiar boundaries of our cosmic neighborhood, Voyager continues its journey. A tiny machine carrying humanity's curiosity into the darkness, still exploring, still listening, and still teaching us that the frontier of discovery is far larger than we ever imagined.